Looking at Saturn's magnificent rings, we encounter one of the most beautiful and perplexing mysteries in our solar system. These shimmering bands of ice and rock have captivated astronomers for centuries, yet despite decades of study with increasingly sophisticated instruments, fundamental questions about their nature remain tantalizingly unanswered. Hey there, how was your day? Wherever you're watching from, whether it's morning, midnight, or somewhere in between, I'm glad you made it. Today, we're heading far beyond the Earth, past the Moon, past Mars, deep into the cold, mysterious edges of our solar system, to a planet that wears its beauty like a crown. This is Saturn, a gas giant cloaked in storms, surrounded by rings so dazzling they once made ancient astronomers believe they were divine. But those rings? They're not what they seem. Some scientists now believe they're disappearing, fast. Others think they should never have existed in the first place. In this video, you'll explore the impossible science of Saturn, its collapsing rings, its bizarre storms, and the haunting question, what is Saturn trying to tell us? The visuals are here for you, but feel free to close your eyes. Let the sound carry you through space, and let's begin our descent into the mystery. When Galileo first pointed his primitive telescope towards Saturn in 1610, he saw what appeared to be handles or ears extending from the planet. His crude instrument couldn't resolve the true nature of what he was observing, leading him to describe Saturn as having a triple form. It wasn't until 1659 that Christian Huygens, using a more powerful telescope, correctly identified these mysterious appendages as a thin, flat ring surrounding the planet. For the next 3.5 centuries, Saturn's rings would continue to reveal new layers of complexity with each technological advance. The single ring Huygens observed was later resolved into multiple distinct bands. Giovanni Cassini discovered the prominent gap that now bears his name, separating what we call the A and B rings. As telescopes improved, astronomers identified additional rings and gaps, creating an intricate system that resembled a cosmic record player spinning in the void. The mystery deepened when scientists began studying the rings' composition. Spectroscopic analysis revealed they were made primarily of water ice, mixed with rocky debris and organic compounds. The particles range in size from microscopic dust grains to house-sized boulders, all orbiting Saturn with mathematical precision. Yet this seemingly simple description masks profound puzzles that continue to baffle researchers today. Perhaps the most fundamental mystery concerns the ring's age. For decades, scientists assumed Saturn's rings were ancient structures, formed billions of years ago during the solar system's tumultuous youth. This assumption seemed logical given Saturn's own age of 4.5 billion years. Surely such a magnificent system would have had eons to develop and stabilize into the complex patterns we observe today. However, recent findings from the Cassini spacecraft, which orbited Saturn from 2004 to 2017, have turned this assumption upside down. The data suggests Saturn's rings may be remarkably young in cosmic terms, perhaps only 100 to 400 million years old. This means the rings could have formed during the age of dinosaurs on Earth, making them relative newcomers to our solar system. This revelation creates a cascade of new questions. If the rings are indeed so young, what catastrophic event could have created them so recently? The leading hypothesis involves the destruction of a large moon, perhaps through a collision with a comet or another moon. The resulting debris would have spread into a disk around Saturn, gradually organizing itself into the ring system we see today. Yet this explanation raises its own puzzles about the mechanics of such destruction and the subsequent evolution of the debris. The ring's pristine appearance also confounds expectations. Over millions of years, bombardment by micrometeorites and cosmic dust should gradually darken the ice particles, much like how fresh snow becomes dirty over time. The fact that Saturn's rings remain brilliantly reflective suggests either they are very young or some unknown process continuously cleans them. Neither explanation sits comfortably with our current understanding of planetary dynamics. Equally mysterious is the rings' incredible thinness relative to their vast extent. Stretching nearly 300,000 kilometers across, the main ring system has a vertical thickness of only about 10 meters in most places. This ratio is even more extreme than a sheet of paper scaled up to the size of a football field. What forces maintain such a compressed structure across such enormous distances? The answer involves a delicate gravitational dance between Saturn, its moons, and the ring particles themselves. Small moons called shepherds orbit near ring edges, their gravity herding particles into narrow bands. Larger moons create resonances that clear gaps or confine particles to specific regions. Yet the precise mechanisms behind these interactions remain poorly understood, and computer simulations struggle to reproduce the ring's exact structure. Saturn's rings also exhibit features that seem to defy conventional physics. Spokes, dark radial markings that rotate with the rings, appear and disappear on timescales of hours. These features shouldn't exist according to our understanding of orbital mechanics, since ring particles at different distances from Saturn orbit at different speeds, which should quickly shear apart any radial structure. The leading explanation involves electrostatic forces lifting tiny dust particles above the ring plane, but the exact mechanism remains uncertain. The rings display an astonishing level of fine structure that becomes more intricate with each improvement in observational capability. What appeared as smooth bands to early telescopes resolved into thousands of individual ringlets when viewed by spacecraft. These ringlets show evidence of waves, braids, and spiral patterns that suggest complex dynamical processes at work. Some features change on timescales of months or years, indicating the ring system is far more dynamic than its serene appearance suggests. Temperature variations across the rings add another layer of mystery. Different regions maintain different temperatures despite receiving similar amounts of sunlight, suggesting variations in particle size, density, or composition that we don't fully understand. Some areas appear to have seasonal temperature changes, implying processes that respond to Saturn's 29-year orbital period around the Sun. The gravitational effects of Saturn's many moons create a symphony of resonances throughout the ring system. These resonances can confine particles, clear gaps, or create waves that propagate through the rings like ripples on a pond. The mathematics describing these interactions is fiendishly complex, involving the three-body problem that has challenged physicists for centuries. While we can identify many resonant features, predicting their exact behavior remains beyond our current capabilities. Recent discoveries have revealed that Saturn's rings may be actively raining material onto the planet's upper atmosphere. This ring rain, composed of water and organic compounds, could be altering Saturn's atmospheric composition and may provide clues about the ring's evolution. The rate of this precipitation suggests the rings are losing mass steadily, which impacts estimates of their age and ultimate fate. The formation mechanism for Saturn's rings remains hotly debated among planetary scientists. The young age indicated by Cassini's data makes a recent catastrophic origin more likely, but the details remain murky. Some models propose the destruction of a large moon through tidal forces as it spiraled too close to Saturn. Others suggest a collision between existing moons. A few theories even propose that the rings formed from the disruption of a passing comet or asteroid. Each formation scenario makes different predictions about the ring's structure and composition, but observational evidence often supports multiple theories simultaneously. The ring's high water ice content suggests they formed from a body that originated in the outer solar system, where ice is abundant. Yet their relatively uniform composition across vast distances is difficult to explain through any single formation event. The discovery of water geysers on Saturn's moon Enceladus, which lies within the ring system, has added new complexity to these formation theories. Enceladus actively feeds Saturn's E-ring with ice particles from its subsurface ocean, demonstrating that at least some ring material comes from active geological processes rather than ancient catastrophes. This raises questions about whether other rings might have similar active sources. Saturn's rings also interact with the planet's magnetic field in ways that continue to surprise scientists. Charged particles become trapped in the magnetic field, creating radiation belts that sculpt the ring's inner and outer boundaries. The rings themselves affect the magnetic field structure, creating a feedback loop between electromagnetic and gravitational forces that we're only beginning to understand. The role of organic compounds in the rings presents another fascinating puzzle. Spectroscopic observations have detected various organic molecules mixed with the ice, giving some regions a reddish tint. The origin of these organics is unclear. They could result from the bombardment of methane-rich comets, the breakdown of organic molecules in Saturn's atmosphere, or even more exotic processes involving the interaction of cosmic rays with ring material. As we continue to study Saturn's rings through ground-based telescopes and plan future missions, each new observation seems to deepen rather than resolve the mystery. The rings appear to be far more complex and dynamic than early astronomers could have imagined, governed by processes that operate across multiple timescales and involve intricate interactions between gravity, electromagnetism, and the mechanical properties of countless individual particles. The beauty of Saturn's rings lies not just in their visual splendor, but in their ability to humble our scientific understanding. Here is a structure we can observe in exquisite detail, whose basic physics we understand, yet whose complete behavior remains tantalizingly beyond our grasp. Welcome to this gentle exploration of one of the cosmos's most beautiful mysteries, where we'll journey together through the shimmering realm of Saturn's rings. Whether you're listening to unwind after a long day or seeking a peaceful passage into sleep, you've found a quiet sanctuary where scientific wonder meets restful contemplation. Tonight, we turn our attention to one of the solar system's most breathtaking spectacles, those ethereal bands of ice and rock that crown Saturn like nature's own celestial jewelry. These rings have captivated humanity for centuries, yet despite our advancing technology and deepening understanding, they remain one of astronomy's most perplexing enigmas. They're simultaneously ancient and impossibly young, delicate yet enduring, simple in concept yet bewilderingly complex in reality. From the moment Galileo first glimpsed what he thought were mysterious handles on Saturn through his primitive telescope in 1610, these rings have whispered secrets that we're still struggling to decode. What he saw as strange appendages, we now know to be one of the most intricate and dynamic systems in our cosmic neighborhood. Yet for all our sophisticated spacecraft and detailed observations, Saturn's rings continue to defy our attempts at complete understanding, revealing new mysteries with each closer look. The rings appear deceptively simple from a distance, smooth bands of light encircling the giant planet like ripples on a cosmic pond. But this simplicity is an illusion, born of vast scale and distance. In reality, Saturn's rings are among the most complex and dynamic structures we've encountered in the solar system. A symphony of gravitational interactions, electromagnetic forces, and particle physics that creates patterns of staggering intricacy and beauty. Consider this remarkable fact. Saturn's rings, despite their enormous span of nearly 300,000 kilometers in diameter, are extraordinarily thin. If you could shrink them down to the size of a football field, they would be thinner than a sheet of paper. This impossible geometry alone hints at the delicate balance of forces at work, where countless particles of ice and rock dance in precise formation, held in their ordained paths by gravitational shepherds and electromagnetic influences we're only beginning to comprehend. The rings consist primarily of water ice, ranging from tiny frost crystals, no larger than grains of sand, to chunks the size of houses, all glittering in the pale sunlight that filters through Saturn's distant atmosphere. Mixed among this cosmic ice are darker materials, rocky debris and organic compounds that paint subtle colors across the ring system and hint at complex chemical processes occurring in the cold vacuum of space. Recent discoveries have only deepened the mystery. The Cassini spacecraft, during its 13-year mission that ended in 2017, revealed that Saturn's rings are far younger than previously thought. 6 billion years ago, they appear to be geological newcomers, perhaps only 100 to 400 million years old. This revelation transformed our understanding and raised profound new questions about their origin and evolution. How could such magnificent structures be so young in cosmic terms? What cataclysmic event could have created them so recently? The leading theories suggest either the destruction of a medium-sized moon that wandered too close to Saturn, torn apart by the planet's immense gravitational forces, or perhaps a collision between two of Saturn's moons that scattered debris into the intricate patterns we observe today. Yet even these explanations leave gaps in our understanding, mysteries that continue to perplex the world's leading planetary scientists. The rings display phenomena that challenge our comprehension of celestial mechanics. There are spokes, mysterious radial features that appear and disappear with Saturn's rotation, defying the simple laws of orbital motion. There are waves, both spiral density waves and vertical corrugations that ripple through the ring material, like frozen tsunamis in space. There are gaps and divisions, some carved by the gravitational influence of Saturn's moons, others appearing for reasons we cannot fully explain. Perhaps most intriguingly, the rings are not the static, unchanging features they appear to be from our earthbound perspective. They're dynamic, evolving systems where material constantly moves and reorganizes itself. Particles collide and stick together, then break apart again. Material spirals inward towards Saturn in a process called ring rain, where charged particles follow magnetic field lines down into the planet's atmosphere. This ongoing evolution means the rings we see today are different from those that existed even a few million years ago, and they will continue to change as eons pass. The electromagnetic environment around Saturn adds another layer of complexity to this cosmic puzzle. The planet's magnetic field interacts with charged particles in the rings, creating phenomena that wouldn't occur in a purely gravitational system. These interactions may be responsible for some of the ring's most mysterious features, including those enigmatic spokes that appear to rotate as solid bodies despite being composed of countless individual particles. The presence of organic materials in the rings raises tantalizing questions about the complex chemistry occurring in this seemingly sterile environment. These compounds, detected by Cassini's sensitive instruments, suggest that even in the cold vacuum of space, interesting chemical processes can unfold over vast periods of time. While we're far from understanding the full implications of these discoveries, they remind us that the universe is capable of surprising complexity in even the most unlikely places. As we continue to study Saturn's rings through ground-based telescopes and plan future missions, each new observation seems to reveal more questions than answers. The rings challenge our models of planetary formation, our understanding of gravitational dynamics, and our assumptions about how planetary systems evolve over time. They serve as a humbling reminder that despite our technological achievements and growing knowledge of the cosmos, nature still holds secrets that tantalize us with their beauty while confounding us with their complexity. Tonight, as you drift towards sleep, perhaps you can imagine yourself floating peacefully among those shimmering particles, each one a tiny world with its own story, all of them together creating one of the most beautiful and mysterious structures in our solar system. Yet the deeper we peer into Saturn's ring system, the more we encounter phenomena that seem to mock our understanding of physics itself. Consider the spokes, mysterious radial features that appear and disappear across the rings like ghostly fingers reaching through the ice. These ethereal formations shouldn't exist according to our models of orbital mechanics. Every particle in the rings follows its own precise gravitational dance around Saturn, with inner particles racing faster than outer ones. Any radial pattern should be sheared apart within minutes, twisted into spiral chaos by the differential rotation that governs ring dynamics. But the spokes persist, appearing suddenly across thousands of kilometers of ring material, rotating as solid structures for hours before fading away. When Voyager first captured these spectral formations in the 1980s, planetary scientists were baffled. Here was Saturn's ring system apparently violating the fundamental laws that govern orbital motion. The particles weren't following gravity's choreography, they were dancing to some other tune entirely. The explanation, when it finally emerged, revealed yet another layer of complexity hidden within the rings. These spokes are electromagnetic phenomena, created when Saturn's powerful magnetic field interacts with tiny dust particles in the rings. Solar ultraviolet radiation and impacts from meteoroids charge these microscopic grains, lifting them briefly out of their orbital plane. For a few precious hours, these electrostatically levitated particles hover above the main ring structure, creating radial patterns that rotate with Saturn's magnetic field, rather than following the gravitational ballet of the larger ring particles. It's a breathtaking example of how multiple forces compete and collaborate within the ring system. Gravity provides the primary structure, holding billions of ice chunks in their elegant orbits. But electromagnetism adds its own subtle influence, occasionally lifting dust grains into temporary liberation from gravitational constraints. The result is a dynamic system where particles can exist in multiple states simultaneously, some following pure orbital mechanics, others dancing to electromagnetic rhythms that pulse with Saturn's 10-hour rotation period. This electromagnetic choreography extends far beyond the mysterious spokes. The entire ring system exists within Saturn's magnetosphere, that invisible bubble of magnetic influence that extends millions of kilometers into space. Charged particles from the solar wind, trapped within this magnetic cocoon, constantly bombard the ring material. This bombardment doesn't just darken the ice over time. It fundamentally alters the chemical and physical properties of ring particles, creating a complex ecosystem of interactions between space weather, magnetism, and matter. The rings themselves influence Saturn's magnetic environment in ways we're only beginning to understand. As ring particles absorb and reflect charged particles, they create gaps and distortions in the planet's radiation belts. The Cassini spacecraft discovered that material from the rings is constantly spiraling inward towards Saturn's atmosphere, carrying with it electromagnetic signatures that reveal the hidden electrical currents flowing through the ring system. It's as if the rings are not just passive collections of ice and rock, but active participants in Saturn's electromagnetic symphony. Perhaps nowhere is this complexity more evident than in the ring system's interaction with Saturn's many moons. These gravitational shepherds don't simply clear gaps in the rings, they actively sculpt and maintain the intricate structure we observe. The moon Prometheus, for instance, creates a braided pattern in the narrow F-ring through a gravitational dance so complex it defies simple description. As Prometheus orbits Saturn, its gravity stretches and compresses sections of the F-ring, sometimes stealing material and sometimes returning it, creating streamers and clumps that evolve over timescales of months and years. Even more mysterious are the phenomena that occur when ring particles venture too close to these shepherding moons. High-resolution images from Cassini revealed that some moons are actually accreting material from the rings, growing larger over time as they sweep up particles from their orbital neighborhoods. Others appear to be shedding material back into the rings, contributing their own substance to the cosmic recycling system that keeps Saturn's rings supplied with fresh material. This constant exchange of matter between rings and moons suggests that Saturn's entire satellite system is far more dynamic than we ever imagined. The rings aren't just debris left over from some ancient catastrophe. They're part of an active, evolving system where matter flows between different reservoirs according to rules we're still struggling to decipher. Some scientists now propose that many of Saturn's smaller moons might actually be recent constructions, assembled from ring material over geological timescales through processes we've only just begun to observe. The temperature structure of the rings adds yet another layer of mystery to this already complex system. While we might expect the rings to have a relatively uniform temperature, determined by their distance from the Sun and Saturn's own thermal radiation, reality proves far more intricate. Different regions of the rings maintain different temperatures, creating thermal patterns that shift and evolve over Saturn's seasonal cycle. These temperature variations influence everything from the physical properties of ice particles to the rate at which ring material migrates between different orbital zones. During Saturn's long winter, when the rings are tilted away from the Sun, they cool dramatically. Ice particles become harder and more brittle, changing how they interact during collisions. The ring system's optical properties shift, altering how efficiently it reflects sunlight and absorbs thermal radiation. When spring arrives and sunlight once again illuminates the rings directly, the warming ice undergoes subtle phase transitions that affect particle adhesion and fragmentation rates. These thermal cycles don't just influence individual particles, they drive large-scale changes in ring structure. As particles heat and cool, their collision properties change, affecting how efficiently they can stick together or break apart. Some regions of the rings appear to undergo seasonal restructuring, with particle size distributions shifting as the thermal environment evolves. It's a reminder that Saturn's rings exist not in the static cold of deep space, but in a dynamic thermal environment that pulses with the rhythm of Saturn's 29-year orbital dance around the Sun. The chemical composition of ring particles adds another dimension to their mystery. While we know the rings are primarily water ice, spectroscopic analysis reveals subtle variations in composition across different regions. Some areas show signs of organic compounds, possibly delivered by impacting comets, or created through radiation processing of methane and other simple molecules. Other regions appear to contain higher concentrations of rocky material, suggesting either different formation processes or varying degrees of contamination from external sources. These compositional variations aren't random. They follow patterns that correlate with ring structure and dynamics. The gaps between rings often show different chemical signatures than the dense ring regions, hinting at different formation mechanisms or evolutionary pathways. Some of the narrowest rings display remarkably pure ice signatures, while broader regions show evidence of complex chemical processing over geological timescales. The discovery of water plumes erupting from Saturn's moon Enceladus has added an entirely new perspective to ring chemistry. These plumes, which feed Saturn's E ring with fresh ice particles, demonstrate that the ring system is not a closed ecosystem, but an open one, constantly receiving new material from active geological processes. The chemical composition of Enceladus's plumes provides clues about the subsurface ocean that feeds them, and by extension, about the processes that might have shaped ring composition throughout Saturn's history. As we continue to study these magnificent structures, each new discovery seems to deepen rather than resolve the fundamental mysteries they represent. Saturn's rings stand as a testament to the universe's capacity for creating beauty and complexity from the simplest ingredients. Looking at the cosmic tapestry we've woven together, we now arrive at perhaps the most spectacular phenomenon in our gravity ballet, the phenomenon that has been quietly shaping cosmic history for billions of years, yet remained hidden from our view until just a few decades ago. This is the story of dark matter, gravity's invisible partner in the cosmic dance. Picture, if you will, the universe as a vast ballroom where we can see only 5% of the dancers. The remaining 95% move through the darkness, their presence known only by how they influence the visible performers around them. This is the reality of our cosmos, where dark matter and dark energy comprise the vast majority of everything that exists, yet remain tantalizingly beyond our direct observation. Dark matter first revealed itself through its gravitational signature in the 1930s, when astronomer Fritz Zwicky noticed something peculiar about the Coma galaxy cluster. The galaxies within this cluster were moving far too quickly to be held together by the gravity of the visible matter alone. According to Newton's laws, they should have been flung apart eons ago, scattered across the cosmos like leaves in a cosmic wind. Yet there they were, bound together in their stately dance, held by some invisible gravitational influence. For decades, this observation remained a curious footnote in astronomical literature. Perhaps the calculations were wrong, or perhaps our understanding of gravity needed refinement. But as our instruments grew more sensitive and our observations more precise, the evidence became undeniable. Galaxy after galaxy, cluster after cluster, all showed the same pattern: too much gravitational influence, too little visible matter to account for it. The breakthrough came in the 1970s when astronomer Vera Rubin turned her attention to the rotation of spiral galaxies. Just as planets in our solar system orbit more slowly the farther they are from the Sun, the outer regions of galaxies should rotate more slowly than their inner regions. The visible matter, stars, gas, and dust, simply couldn't provide enough gravitational pull to keep the outer edges spinning at the speed she observed. But that's not what Rubin found. Instead, she discovered that the outer regions of galaxies rotated at nearly the same speed as their inner regions, as if some invisible mass were distributed throughout the galaxy, providing the extra gravitational influence needed to maintain these rapid rotation rates. It was as if each galaxy were embedded in a vast halo of invisible matter, detectable only through its gravitational effects on the visible cosmos. This invisible scaffolding, which we now call dark matter, appears to outweigh ordinary matter by a factor of 5 to 1. It doesn't emit light, doesn't absorb light, and doesn't interact with electromagnetic forces in any way we can detect. It reveals itself only through gravity, the most universal and inescapable of nature's forces. Dark matter is, in essence, gravity's secret partner, the invisible choreographer that guides the cosmic dance from behind the scenes. Computer simulations have shown us what this dark matter scaffolding looks like on the largest scales. It forms a vast cosmic web, with dark matter filaments stretching across hundreds of millions of light years, connecting dense nodes where galaxy clusters form. Along these invisible highways, ordinary matter flows like cosmic rivers, channeled by dark matter's gravitational influence into the structures we observe today. Without dark matter, the universe would be a very different place. Galaxies would be smaller, less stable, and far more scattered. The cosmic web that organizes matter on the largest scales would never have formed. The gentle gravitational influences that allowed our own galaxy to develop its elegant spiral structure would be absent. Earth itself might never have formed, as the gravitational processes that built our solar system depended on the dark matter environment that surrounded and shaped our cosmic neighborhood. As we drift deeper into this cosmic mystery, we encounter dark matter's even more enigmatic companion, dark energy. While dark matter works with gravity to build cosmic structures, dark energy works against it, driving the accelerating expansion of the universe itself. Discovered in 1998 through observations of distant supernova, dark energy appears to be a property of space itself, causing empty space to expand at an ever-increasing rate. The interplay between these invisible forces creates a cosmic drama played out over billions of years. In the early universe, when matter was more densely packed, gravity and dark matter dominated, pulling together the first stars and galaxies. But as the universe expanded and matter became more spread out, dark energy began to win the cosmic tug-of-war. accelerating the expansion and ensuring that future galaxy formation would become increasingly difficult. This cosmic balance point, where dark energy overcame the gravitational pull of dark matter, occurred roughly 5 billion years ago, coincidentally around the time our solar system was forming. We live in a universe poised between construction and dissolution, where local structures can still form and evolve while the larger cosmic web slowly stretches and disperses. The implications of this invisible universe are profound. Every step you take, every breath you draw, occurs within a sea of dark matter particles streaming through your body at hundreds of kilometers per second. You are not separate from this cosmic dance, but immersed in it, surrounded by invisible dancers whose gravitational influence helps shape the very atoms of which you are made. Modern particle physics suggests that dark matter may consist of exotic particles that interact only through gravity and the weak nuclear force, making them nearly impossible to detect directly. Underground laboratories around the world are attempting to catch these elusive particles as they drift through the Earth, while particle accelerators try to create them in high-energy collisions. Each experiment brings us closer to understanding the nature of this invisible majority that shapes our cosmic destiny. As you settle into sleep tonight, remember that you are not resting in empty space, but floating in an ocean of dark matter, held gently by Earth's gravity while embedded in the vast cosmic web that connects every galaxy to every other galaxy across the observable universe. The invisible dancers that surround you have been performing their patient ballet for nearly 14 billion years, and they will continue long after the last star has faded and the universe has expanded into its ultimate, cold, dark fate. In this cosmic dance between the seen and unseen, the visible and invisible, we find perhaps the most beautiful expression of gravity's universal reach. It is a force that works through matter we can touch and matter we cannot even detect, weaving together the entire cosmos in an intricate web of gravitational relationships that spans from the smallest scales to the largest structures in the universe. The gravity ballet continues, with dark matter as its invisible principal dancer, guiding the cosmic choreography with patient, persistent influence that shapes everything, from the formation of the first stars to the gentle tug you feel holding you to your bed. Saturn's rings, a beautiful mystery. Science still can't explain. Part 5. But perhaps the most profound mystery surrounding Saturn's rings lies in their very existence. You see, according to our best understanding of celestial mechanics, these magnificent structures should have vanished long ago. The same gravitational forces that sculpted them into such exquisite patterns should have by now pulled them into chaos. Yet here they persist, defying our expectations like cosmic rebels dancing to their own rhythm. The mystery deepens when we consider what astronomers call the ring rain phenomenon. Every second, tons of ring material are literally falling into Saturn's atmosphere, pulled downward by the planet's immense gravity. This isn't a gentle sprinkling, but a constant deluge of ice particles, each one carrying with it a piece of the ring system's history. At this rate of loss, the rings should have been completely consumed millions of years ago, leaving behind only the faintest whisper of their former glory. Think about that for a moment. You're witnessing something that, by all rights, shouldn't exist. It's as if you discovered a sandcastle on a beach during a storm, perfectly preserved despite the waves that should have washed it away hours ago. The rings are Saturn's impossible sandcastle, maintained by forces we're only beginning to understand. Recent discoveries have revealed that the rings are far more active than we ever imagined. The Cassini spacecraft, during its grand finale mission, detected what scientists call spokes, mysterious dark features that appear and disappear across the rings like ghostly fingers. These spokes seem to be created by electromagnetic forces, possibly triggered by Saturn's magnetic field interacting with the charged particles in the rings. It's a phenomenon that transforms the rings from a static display into a living, breathing entity. The rings also exhibit what can only be described as weather patterns. Temperature variations create waves that ripple through the ice particles, causing them to clump together in some regions while spreading apart in others. During Saturn's long seasons, each lasting about 7 Earth years, these temperature changes create a slow-motion dance of expansion and contraction that reshapes the ring structure over time. But here's where the story becomes truly extraordinary. The rings aren't just passive collections of debris, they're active participants in Saturn's entire atmospheric system. The ring rain we mentioned earlier isn't just draining the rings away, it's actually changing Saturn's atmosphere itself. The water from the rings is altering the chemical composition of Saturn's upper atmosphere, creating a feedback loop between the planet and its ornamental crown. This interaction extends beyond mere chemistry. The rings cast shadows on Saturn's surface, creating temperature variations that influence the planet's weather patterns. Conversely, Saturn's magnetic field reaches out to embrace the rings, creating electrical currents that flow through the ice particles like a vast cosmic circuit. The planet and its rings are locked in an intimate dance, each partner influencing the other in ways we're still discovering. The gravitational relationship between Saturn and its rings is perhaps the most complex example of celestial mechanics in our solar system. Each ring particle follows its own precise orbit, influenced not only by Saturn's gravity, but by the gravitational pull of dozens of moons, some large and some tiny. The larger moons act as shepherds, using their gravity to maintain the sharp edges of certain rings, while smaller moonlets embedded within the rings create gaps and waves through their gravitational influence. These shepherd moons perform their duties with remarkable precision. Prometheus and Pandora, 2 small moons flanking the narrow F ring, work together to keep this ring from spreading out into space. Their gravitational tugs create a delicate balance, constantly adjusting the ring's shape and preventing it from dissipating. It's as if the solar system has its own team of cosmic gardeners, carefully tending to Saturn's magnificent display. The mystery extends to the very origin of the rings themselves. While we know they're relatively young in cosmic terms, the exact mechanism of their formation remains hotly debated. Did a moon venture too close to Saturn and get torn apart by tidal forces? Was it a collision between 2 of Saturn's moons that scattered debris across the planet's equatorial plane? Or perhaps a comet, rich in water ice, met its fate in Saturn's gravitational embrace? Each theory has its supporters and its problems. The tidal disruption theory explains the rings' composition and location beautifully, but struggles to account for their youth. The collision theory could explain the sudden appearance of the rings, but leaves questions about why the debris didn't simply fall into Saturn or escape into space. The comet theory is appealing in its simplicity, but comets typically don't contain enough material to create such an extensive ring system. What makes this mystery even more intriguing is the discovery that the rings are not uniform in age. Some regions appear older than others, suggesting that the ring system has been constantly renewed and reshaped throughout its existence. It's as if Saturn's rings are not a single structure, but a collection of different ring systems, each with its own history and timeline. The chemical composition of the rings adds another layer to the puzzle. While they're primarily made of water ice, they also contain traces of rocky material and organic compounds. These organic molecules, the building blocks of life as we know it, are being constantly created and destroyed in the harsh environment of the ring system. It's a cosmic chemistry laboratory, conducting experiments on a scale that dwarfs anything we could create on Earth. The rings also serve as a time machine, preserving clues about the early solar system. The ice particles that make up the rings may contain primordial material from the formation of Saturn itself, locked in frozen silence for billions of years. By studying the rings, we're not just learning about Saturn today, but about the conditions that existed when our entire solar system was young. Perhaps most remarkably, the rings are teaching us about the fundamental nature of matter itself. The way ice particles interact within the rings, clumping together and breaking apart, provides insights into how planets form from cosmic dust. The rings are a natural laboratory for studying accretion, the process by which small particles come together to form larger structures. In a very real sense, Saturn's rings are showing us how worlds are born. As we continue to study these magnificent structures, new mysteries emerge with each observation. The rings' ability to heal themselves after meteorite impacts, their seasonal variations, their electromagnetic properties, all point to a system far more complex and dynamic than we initially imagined. They're not just beautiful, they're a testament to the incredible complexity that can emerge from the simple laws of physics. The rings of Saturn remind us that the universe is full of wonders that challenge our understanding. They exist in defiance of our expectations, maintained by forces we're still working to comprehend. In their impossible beauty, they whisper secrets about the nature of gravity, the behavior of matter, and the delicate balance that allows such magnificent structures to exist. Tonight, as you look up at the stars, remember that somewhere out there, Saturn continues its ancient dance, its rings catching and reflecting the light of our distant sun. They're a reminder that the universe is far stranger and more wonderful than we dare imagine, full of mysteries that continue to inspire and humble us. Saturn's rings, a beautiful mystery science still can't explain. Part 6 of 12. But the true mystery of Saturn's rings isn't just their youthful appearance or their impossible thinness, it's how they've managed to survive at all in the chaotic neighborhood of space. You see, Saturn's rings exist in what scientists call a gravitational shooting gallery, where countless forces are constantly trying to tear them apart. Every moment of every day, Saturn's rings are under assault. Micrometeorites pepper them like cosmic hail, each impact sending ice particles spinning off into space. The solar wind, that relentless stream of charged particles flowing from our sun, gradually erodes the ring material grain by grain. And then there's Saturn itself, whose powerful magnetic field creates invisible storms that can scatter ring particles across vast distances. Yet somehow, against all odds, the rings persist. They maintain their structure, their gaps, their intricate patterns. It's as if they're being constantly rebuilt, constantly replenished, constantly maintained by some invisible cosmic gardener. But what could possibly be doing this maintenance work? The answer might lie in Saturn's family of moons. These celestial shepherds, as astronomers call them, orbit in perfect synchronization with the ring system, their gravitational influence carving out gaps and maintaining boundaries with clockwork precision. The moon Mimas, for instance, creates the famous Cassini division, that dark gap between the A and B rings that's wider than the distance between Earth and our moon. Every time a ring particle ventures into this forbidden zone, Mimas's gravity gives it a gentle but persistent nudge, eventually ejecting it from the area entirely. But the moons do more than just create gaps. They also seem to be feeding the rings. When the Cassini spacecraft analyzed the composition of Saturn's rings in exquisite detail, it discovered something remarkable. The rings contain traces of material that could only have come from the moons themselves. Tiny particles of rock and organic compounds, the signatures of ancient impacts and ongoing erosion, are scattered throughout the icy ring system like breadcrumbs marking a cosmic trail. This discovery has led to one of the most intriguing theories about ring maintenance. Perhaps the rings are constantly being resupplied by their moon shepherds. When meteorites strike these small moons, they blast material into space. Some of this debris gets captured by Saturn's gravity and incorporated into the ring system, providing fresh material to replace what's been lost to erosion and bombardment. It's a beautiful concept, really. The rings and moons locked in an eternal dance of destruction and renewal, with the moons sacrificing tiny pieces of themselves to keep the rings alive. But like so many explanations for Saturn's rings, this one raises more questions than it answers. If the moons are constantly feeding the rings, why aren't the rings growing thicker over time? What determines how much material gets added and where it goes? The more we study Saturn's rings, the more we realize that they're not just a static collection of ice and rock, but a dynamic, living system. The Cassini mission revealed that the rings have weather patterns with storms of charged particles creating temporary disturbances that can last for months. They have seasons, changing subtly as Saturn's tilted axis carries them through their 29-year cycle of solstices and equinoxes. They even have a kind of geology, with different regions displaying distinct characteristics and compositions. Perhaps most remarkably, the rings appear to be active participants in Saturn's global climate system. The ring rain we discussed earlier doesn't just drain material from the rings, it actually affects Saturn's atmosphere. The infalling ice particles carry electrical charges that interact with Saturn's magnetic field, creating aurora displays and heating the planet's upper atmosphere. In essence, Saturn's rings are slowly cooking their parent planet from the inside out. This connection between rings and planet runs deeper than anyone expected. Computer simulations suggest that Saturn's rings might actually influence the planet's rotation rate, acting like a cosmic brake that gradually slows the giant world's spin. Over millions of years, this effect could be significant enough to alter Saturn's weather patterns, its magnetic field, and even the orbits of its moons. But here's where the mystery deepens even further. If Saturn's rings are so young, so dynamic, and so intimately connected to the planet's evolution, what does that tell us about the rings of other worlds? Jupiter has rings, though they're faint and made primarily of dust. Uranus and Neptune have rings too, dark and narrow bands that seem almost like shadows compared to Saturn's brilliant display. Are all these ring systems young? Are they all temporary features, cosmic mayflies that bloom and fade on timescales that are brief, even by astronomical standards? Or is Saturn somehow special, the only world in our solar system capable of maintaining a spectacular ring system over long periods? The answer might lie in the delicate balance of forces that govern ring dynamics. Saturn occupies a unique position in our solar system, massive enough to hold on to complex ring systems, but not so massive that it destroys them through tidal forces. Its distance from the Sun provides the perfect environment for water ice to remain stable, while its family of moons creates the gravitational architecture necessary for ring maintenance. But even this explanation feels incomplete. We've discovered ring systems around other planets throughout the galaxy, some even more spectacular than Saturn's. The exoplanet J1407b, located 400 light-years away, appears to have a ring system so massive and complex that it would span the distance from Earth to the Sun if placed in our solar system. If ring systems can exist on such scales around other worlds, why is Saturn's system so unique in our own cosmic neighborhood? Perhaps the answer lies not in the rings themselves, but in our perspective. We're observing Saturn's rings at a particular moment in cosmic history, during a brief window when they happen to be at their most spectacular. Billions of years from now, when the last of the ring material has rained down onto Saturn's surface, future astronomers might look at the planet and see only a faint, dusty remnant of what once was. Or perhaps they'll see something entirely different. Maybe Saturn's rings are not dying but transforming, evolving into something we can't yet imagine. The same forces that create the ring rain might also be creating new structures, new patterns, new mysteries that we haven't even begun to understand. This is the beautiful paradox of Saturn's rings. The more we learn about them, the more mysterious they become. Every answer leads to new questions. Every discovery reveals new depths of complexity. They challenge our understanding of planetary formation, celestial mechanics, and the very nature of how complex systems organize themselves in the cosmos. As we continue to study these magnificent structures, using ever more sophisticated instruments and techniques, we're not just unraveling the secrets of Saturn's rings. We're gaining insights into the fundamental processes that shape all planetary systems, including our own. The same forces that sculpt Saturn's rings also influence the distribution of asteroids in our solar system, the formation of planetary moons, and even the evolution of planetary atmospheres. In the end, Saturn's rings remain what they have always been, a beautiful mystery that continues to inspire wonder and drive scientific discovery. They remind us that the universe is far stranger and more wonderful than we often imagine, full of phenomena that challenge our preconceptions and push the boundaries of our understanding. The delicate dance between Saturn's rings and its moons reveals one of the most intricate gravitational ballets in our solar system, a performance so precise that it challenges our understanding of celestial mechanics itself. These aren't just random chunks of ice and rock orbiting a distant world, but participants in a choreography so complex that each particle knows its place in a symphony conducted by forces we're only beginning to comprehend. Consider for a moment the sheer audacity of what we're witnessing. Here, in the cold depths of space, billions upon billions of individual particles maintain their positions in structures thinner than a sheet of paper relative to their width, yet spanning distances that could swallow our entire planet. The rings persist not despite the chaotic gravitational environment around Saturn, but because of it. Every shepherd moon, every orbital resonance, every gravitational nudge contributes to a system of such exquisite balance that it seems almost designed. The shepherd moons present us with perhaps the most elegant example of this cosmic choreography. Prometheus and Pandora, those twin guardians of the F-ring, dance their eternal waltz just inside and outside the ring's boundaries. Their gravitational influence creates a containment system so effective that it can corral particles into a structure barely a few kilometers wide, while stretching across thousands of kilometers of space. When Prometheus approaches the ring material during its slightly faster orbit, it gravitationally tugs particles forward, accelerating them into higher orbits. Meanwhile, Pandora, orbiting more slowly on the ring's outer edge, pulls particles backward, slowing them down and keeping them from escaping into space. This isn't a gentle, steady influence. The shepherd moons create what scientists call braided structures in the F-ring, where strands of particles weave in and out of each other in patterns that shift and evolve over time. Voyager images showed us these braids forming and dissolving like cosmic hair being styled by invisible hands. Later, Cassini revealed that these structures are far more dynamic than anyone had imagined, with new braids appearing and old ones fading away in a constant state of gravitational flux. But the F-ring's behavior goes beyond simple shepherding. The ring exhibits what can only be described as spontaneous creativity. Bright knots of material appear and disappear seemingly at random. Spiral structures wind outward from the ring core like galactic arms in miniature. Jets of particles stream away from the main ring body, creating temporary spokes that extend for hundreds of kilometers before dispersing back into the general population. These phenomena suggest that the ring system is far more active and responsive than our models predicted. The mystery deepens when we consider the ring's response to small moonlets embedded within it. These tiny bodies, some no larger than a few kilometers across, create wakes and gaps in the ring material as they orbit. But rather than simply clearing a path, These moonlets seem to organize the surrounding particles into complex patterns. Some create spiral density waves that propagate outward like ripples on a pond. Others generate what appear to be temporary moons, clumps of material that orbit the moonlet for a time before dispersing or being swept away by other gravitational influences. Pan, the small moon that orbits within the Encke Gap, provides another stunning example of this gravitational artistry. As it travels through the gap, Pan doesn't simply clear the space of particles. Instead, it sculpts the ring material at the gap's edges into vertical structures that rise above and below the ring plane like walls. These structures, discovered by Cassini, extend several kilometers above the ring plane and create what astronomers have dubbed the wavemaker effect. The moon's gravity pulls ring particles up out of the plane as it passes, creating temporary mountains and valleys in what should be a perfectly flat disk. Even more intriguing is the discovery that some of these shepherd moons appear to be creating and destroying ring material through their interactions. When Prometheus makes its closest approach to the F ring, it doesn't just reorganize existing particles. It appears to strip material from the ring, creating streamers and channels that persist for months before being reabsorbed. Some scientists speculate that this process might be one way the rings maintain their mass over time, with moons both removing and redistributing material in an ongoing cycle of destruction and renewal. The Cassini division, that prominent gap between the A and B rings, tells its own story of gravitational precision. This gap exists because any particle orbiting at that distance would be in a 2-to-1 resonance with the moon Mimas. Every 2 orbits of a hypothetical particle would correspond to exactly 1 orbit of Mimas, creating a regular gravitational tug that would gradually perturb the particle's orbit until it either moved inward or outward, leaving the resonance zone empty. It's a cosmic example of how even distant gravitational influences can sculpt structure with mathematical precision. Yet the Cassini division isn't entirely empty. Careful observations have revealed faint ringlets within the gap, maintained by their own complex dynamics. These ghostly structures challenge our understanding of how resonances work. They suggest that the gravitational environment around Saturn is so rich and complex that particles can find stable orbits, even in regions where simple theory predicts they shouldn't exist. The spoke phenomena in the B ring present perhaps the most puzzling aspect of Saturn's ring dynamics. These dark wedge-shaped features appear to rotate with Saturn's magnetic field rather than following orbital mechanics. They form near Saturn's dawn terminator, where sunlight first strikes the ring particles and gradually fade as they rotate toward the evening side. The spokes seem to be related to electromagnetic forces rather than purely gravitational ones, suggesting that Saturn's rings exist at the intersection of multiple physical regimes. The formation mechanism for spokes remains hotly debated. Some scientists propose that micrometeorite impacts charge ring particles, causing them to levitate above the ring plane under the influence of Saturn's magnetic field. Others suggest that the spokes are created by electromagnetic disturbances in Saturn's magnetosphere that propagate through the ring system. Whatever their origin, the spokes demonstrate that Saturn's rings are not just gravitational structures, but complex systems where magnetic, electrical, and mechanical forces all play important roles. The seasonal changes in Saturn's rings add another layer of complexity to this already intricate system. As Saturn orbits the Sun every 29.5 years, the angle at which sunlight strikes the rings changes dramatically. When the rings are tilted toward the Sun, they heat up and expand slightly. When they're tilted away, they cool and contract. These thermal cycles create subtle changes in the ring structure that can persist for years. During Saturn's equinox, when the Sun shines directly on the ring plane's edge, the rings nearly disappear from view because they're so thin. But this geometric alignment also reveals structures that are normally hidden. Vertical features cast shadows across the ring plane, revealing the three-dimensional nature of structures that appear flat when viewed from above. Mountains and ridges in the rings, sculpted by embedded moonlets and gravitational resonances, suddenly become visible as towering structures that dwarf Earth's highest peaks. The discovery of propeller-shaped features in the A-ring has opened yet another window into the ring's complex dynamics. These features, created by moonlets too small to be seen directly, appear as dark and bright streaks that extend for hundreds of kilometers. The propeller shape results from the moonlet's gravitational influence on surrounding particles, creating a pattern that rotates with the moonlet as it orbits Saturn. Some of these propellers have been tracked for years, allowing scientists to study how embedded objects interact with ring material over time. What makes these observations so remarkable is their implication for our understanding of planetary formation. The processes we see in Saturn's rings, the accretion and dispersal of material, the gravitational shepherding, the complex interactions between small bodies and surrounding debris, all of these phenomena likely played crucial roles in the formation of planets throughout the solar system. Saturn's rings provide us with a natural laboratory where we can observe these processes in action, a cosmic wind tunnel where the fundamental physics of planetary formation plays out on scales we can actually observe and measure. The sheer persistence of these structures, despite the forces working against them, suggests that Saturn's rings are far more resilient than we initially believed. They're not passive collections of debris slowly spiraling into the planet, but active, dynamic systems that respond to perturbations by reorganizing and adapting. This resilience might help explain how they've survived for hundreds of millions of years in an environment that should have destroyed them long ago. As we continue to analyze data from the Cassini mission and prepare for future explorations of the Saturn system, each new discovery reveals additional layers of complexity in this gravitational masterpiece. The rings of Saturn stand as testament to the universe's ability to create beauty and order from apparent chaos, to transform simple physical laws into structures of breathtaking complexity and elegance. The deeper we peer into Saturn's ring system, the more we discover that our understanding barely scratches the surface of its true complexity. For every question we answer about these magnificent structures, 3 more mysteries emerge from the shadows, each more perplexing than the last. It's as if the rings themselves are deliberately keeping their secrets, revealing just enough to tantalize us while holding back the profound truths that lie at the heart of their existence. Consider the fundamental question that has haunted researchers for decades. Why do Saturn's rings exist at all? Not just how they formed, but why they persist in defying every theoretical prediction about their demise. According to our best models, these delicate structures should have been ground to dust billions of years ago, their particles either spiraling into Saturn's atmosphere or dispersing into the void of space. Yet here they are, as vibrant and structured as ever, spinning their eternal dance around the planet with an almost mocking disregard for our calculations. The mystery deepens when we examine the intricate wave patterns that ripple through the rings like frozen music. These density waves, spiral waves, and bending waves create patterns of breathtaking mathematical beauty. Yet their precise mechanisms remain tantalizingly out of reach. We can observe the waves, we can measure their wavelengths and frequencies, but the underlying physics that creates and maintains these patterns continues to elude our complete understanding. It's as if we're watching a cosmic symphony being performed, hearing every note clearly, but unable to read the sheet music that orchestrates the entire composition. Perhaps nowhere is this mystery more apparent than in the phenomenon of the ring spokes, those ghostly radial features that appear and disappear like phantoms in the night. Despite decades of observation and countless theoretical models, we still cannot definitively explain how these spokes form, why they follow the patterns they do, or what determines their appearance and disappearance. They seem to exist in a realm between the purely gravitational and the electromagnetic, influenced by forces we can measure but cannot fully comprehend. The spokes appear to be connected to Saturn's magnetic field, yet they behave in ways that suggest influences we haven't yet identified or properly understood. The propeller structures present another layer of mystery that continues to confound our expectations. These small, persistent features, shaped like airplane propellers embedded in the rings, appear to be created by moonlets too small to observe directly. Yet their behavior suggests a complex interplay between gravitational forces, particle dynamics, and perhaps electromagnetic effects that we're only beginning to appreciate. Some propellers persist for years, maintaining their shape and position with remarkable stability, while others appear and vanish seemingly at random. The governing principles behind their formation and evolution remain one of the ring system's most stubborn secrets. Temperature variations across the rings present yet another puzzle that defies easy explanation. The rings exhibit temperature patterns that don't always correlate with what we'd expect from simple solar heating. Some regions appear warmer than they should be, while others remain mysteriously cool. These temperature anomalies suggest energy sources or dissipation mechanisms that we haven't fully identified. The thermal properties of the ring particles themselves seem to vary in ways that hint at compositional differences or structural arrangements that remain largely invisible to our instruments. The role of Saturn's magnetosphere in ring dynamics continues to present challenges that push the boundaries of our understanding. The planet's magnetic field permeates the ring system, creating a complex environment where charged particles interact with ring material in ways that are both subtle and profound. The aurorae that dance around Saturn's poles are intimately connected to ring processes, yet the exact mechanisms of this connection remain partially obscured. We observe the effects clearly, but the underlying physics involves processes so intricate and interdependent that our models can only approximate their true complexity. Color variations throughout the rings tell stories we're still learning to read. The subtle differences in hue and brightness across different regions suggest variations in particle composition, size distribution, or surface properties that we can detect but not fully explain. Some areas appear more reddish, others more blue, and these color patterns seem to correlate with age, composition, or exposure to different environmental conditions. Yet, the precise relationship between color and the underlying physical properties remains a subject of active investigation and debate. The vertical structure of the rings presents mysteries that challenge our understanding of how thin disk systems maintain their organization. While the rings appear remarkably flat when viewed from afar, closer examination reveals complex vertical motions and structures that suggest processes we're only beginning to understand. The rings breathe, expanding and contracting vertically in response to gravitational and electromagnetic influences that create a three-dimensional dance of particles extending far beyond the simple flat disk we once imagined. Edge effects at ring boundaries create phenomena that seem to violate our expectations about how particle systems should behave. The sharp edges of some rings maintain their definition despite the constant bombardment and gravitational perturbations that should blur these boundaries. The mechanisms that create and maintain these sharp transitions remain partially mysterious, involving processes that operate on scales from individual particles to entire ring segments. The interaction between ring particles and Saturn's atmosphere presents another frontier of mystery. The planet's upper atmosphere extends into the ring plane, creating drag forces that should cause rapid orbital decay. Yet the rings persist, suggesting replenishment mechanisms or protective processes that counteract atmospheric drag in ways we don't fully understand. The exchange of material between rings and atmosphere appears to be more complex and dynamic than our models predict. Perhaps most intriguingly, the rings seem to exhibit behaviors that suggest a kind of collective intelligence, responding to perturbations in ways that maintain overall system stability. When disrupted by impacts or gravitational disturbances, the rings appear to heal themselves, redistributing material and energy to restore equilibrium. This self-organizing behavior hints at underlying principles that we're only beginning to recognize and understand. The mystery extends to the very nature of ring-particle interactions. While we understand the basic physics of collisions and gravitational forces, the collective behavior of trillions of particles creates emergent properties that transcend our ability to predict from first principles. The rings exhibit behaviors that seem to arise from the complex interplay of countless individual interactions, creating patterns and structures that are more than the sum of their parts. These enduring mysteries remind us that Saturn's rings are not merely collections of ice and rock orbiting a distant planet. They are dynamic, evolving systems that embody physical processes and principles we're still working to understand. Each new observation, each improved instrument, each theoretical breakthrough brings us closer to comprehending their true nature, yet also reveals new depths of complexity that humble our scientific ambitions. The rings continue to challenge our understanding of celestial mechanics, particle physics, electromagnetic interactions, and the fundamental processes that govern matter in space. They serve as a natural laboratory where extreme conditions and vast scales create phenomena that cannot be replicated on Earth, offering insights into processes that operate throughout the universe. The rings of Saturn, a dance of gravitational precision. What we're witnessing around Saturn represents one of the most intricate expressions of gravitational choreography in our solar system. While we've explored the grand cosmic ballet of galaxies and planetary formation, Saturn's rings offer us an intimate view of how gravity operates on a more delicate scale, creating structures so precise they challenge our understanding of celestial mechanics. Picture, if you will, the rings as a vast cosmic record player, spinning with such mathematical perfection that each particle of ice and rock follows its own orbital path with clockwork precision. These aren't solid structures as they might appear from a distance, but rather billions upon billions of individual fragments, each one a tiny moon in its own right, dancing in perfect synchronization around the gas giant's equator. The beauty lies in the details. Saturn's rings extend outward from the planet in a series of distinct bands, each one maintained by a complex web of gravitational relationships. The famous Cassini division, that dark gap between the A and B rings, exists because particles there would complete exactly 2 orbits for every 1 orbit of Saturn's moon Mimas. This gravitational resonance creates a zone of instability, gradually sweeping the area clear of debris over millions of years. But it's not just the major gaps that tell this story of gravitational precision. Throughout the ring system, we find intricate patterns that speak to the delicate balance between competing forces. Shepherd moons, tiny satellites that orbit just inside and outside certain rings, use their gravitational influence to maintain sharp ring edges. Like cosmic border guards, they prevent the ring particles from spreading outward or drifting inward, creating boundaries so precise they appear almost artificial. The ring particles themselves exist in a constant state of gentle collision and gravitational negotiation. Too much energy, and they would spiral inward towards Saturn or escape outward into space. Too little, and they would clump together into larger bodies. Instead, they maintain this perfect balance, creating a system so stable it has persisted for what may be hundreds of millions of years. What makes this gravitational dance even more remarkable is its ephemeral nature. Despite their apparent permanence, Saturn's rings are constantly evolving. The planet's magnetic field channels charged particles from the solar wind, which interact with the ring material and gradually erode it. At the same time, micrometeorite impacts and the gentle gravitational pull of Saturn itself cause ring material to slowly spiral inward, creating what scientists call ring rain as particles fall into the planet's atmosphere. This process suggests that Saturn's rings, for all their grandeur, are relatively young by cosmic standards. Rather than being primordial features dating back to the formation of the solar system, they may be the result of a more recent catastrophic event, perhaps the breakup of a large moon or the capture and destruction of a passing comet. In cosmic terms, we may be witnessing Saturn's rings during their brief moment of glory, a fleeting display of gravitational artistry that will gradually fade over the next 100 million years. The precision of this system extends beyond what we can see with our eyes. The Cassini spacecraft revealed that Saturn's rings contain structures that appear and disappear on timescales of hours or days. Ghostly spokes of material that form and dissipate like shadows on the ring plane. These phenomena hint at electromagnetic forces working in concert with gravity, creating a dynamic system where particles can be lifted above the ring plane and redistributed in patterns that still puzzle scientists. As we drift deeper into contemplation of these cosmic mechanisms, we begin to appreciate that Saturn's rings represent more than just a beautiful astronomical phenomenon. They serve as a natural laboratory for understanding how gravitational forces shape matter on scales both large and small. The same principles that govern the motion of ring particles also influence the formation of planetary systems, the structure of galaxies, and the evolution of the universe itself. In the gentle dance of Saturn's rings, we see gravity not as a harsh master pulling everything toward destruction, but as a patient artist, carefully sculpting beauty from chaos, creating order from randomness, and maintaining a delicate balance that allows for both stability and change. Each particle in those rings follows its own perfect orbit, contributing to a collective masterpiece that has inspired wonder and scientific inquiry for centuries. Tonight, as you rest beneath the same gravitational forces that shape Saturn's rings, remember that you too are part of this cosmic dance. The same mathematical principles that maintain the elegant structure of those distant rings also govern the motion of our planet, the flow of our atmosphere, and even the circulation of blood through your veins. In the grand symphony of gravitational forces, every note matters, every movement contributes to the whole, and every moment of this celestial performance is both ancient and eternally new. The dance of cosmic deception. We've journeyed through the birth of galaxies and witnessed gravity's grand choreography across the universe. But now, we encounter one of the most perplexing puzzles in all of cosmic science. Saturn's rings, those magnificent bands of ice and rock that have captivated humanity for centuries, harbor secrets that challenge everything we thought we knew about planetary formation and the very nature of time itself. Picture this. You're floating in space, approaching Saturn for the first time. The planet looms before you, a pale golden giant wrapped in what appears to be the most delicate lacework imaginable. Thousands upon thousands of individual ringlets stretch out in perfect concentric circles, each one shepherded by invisible gravitational forces into mathematical precision. The sight is so breathtaking, so impossibly beautiful, that early astronomers could barely believe their eyes when they first glimpsed these celestial ornaments through their primitive telescopes. But here's where the mystery deepens into something almost unsettling. These rings, which appear so ancient and eternal, may be younger than the dinosaurs that once walked the Earth. While Saturn itself formed over 4 billion years ago in the early days of our solar system, mounting evidence suggests that its spectacular ring system might have appeared only a few 100 million years ago. It's as if someone recently hung the most exquisite chandelier in a palace that had stood empty for eons. How can something so magnificent so seemingly permanent, be so ephemeral in cosmic terms? The answer lies in a delicate dance between creation and destruction, between the forces that build these celestial structures and those that relentlessly tear them apart. Every moment, Saturn's rings are being bombarded by micrometeorites, tiny space debris that darkens the pristine ice particles and slowly grinds them to dust. Yet despite these destructive forces, the rings persist in their gossamer beauty. They're maintained by an intricate ballet of gravitational resonances, where Saturn's many moons act as cosmic shepherds, their gravitational influence creating gaps, sculpting edges, and somehow maintaining the ring system's stunning complexity. The moon Mimas, for instance, creates the prominent Cassini division through its gravitational resonance, while tiny embedded moonlets carve out narrow gaps and maintain the sharp edges of individual ringlets. But perhaps the most mysterious aspect of Saturn's rings isn't their age or their maintenance, but their very existence. Why does Saturn alone among the gas giants possess such a spectacular ring system? Jupiter, Uranus, and Neptune all have rings, but they're faint, sparse affairs compared to Saturn's magnificent display. It's as if Saturn received some cosmic gift that its siblings were denied, a celestial crown that seems almost too perfect to be natural. The rings themselves are a study in contradictions. They appear solid from a distance, yet they're composed of countless individual particles ranging in size from tiny ice crystals to house-sized boulders. They seem perfectly circular, yet they're actually slightly elliptical, pulsing gently like a cosmic heartbeat. They look uniform in color, yet close examination reveals subtle variations in hue that tell stories of different compositions and origins. Recent discoveries have only deepened the mystery. The Cassini spacecraft, during its 13-year mission around Saturn, revealed structures within the rings that seem to defy explanation. Spokes of dark material appear and disappear in the rings like ghostly fingers, their formation linked to Saturn's magnetic field in ways we're still trying to understand. Propeller-shaped gaps created by small moonlets open and close as these tiny shepherds orbit within the rings, creating dynamic patterns that change over timescales of hours and days. Even more puzzling are the ring particles themselves. They're almost pure water ice, far cleaner than they should be given the constant bombardment of space debris. It's as if some cosmic janitor is constantly cleaning them, maintaining their pristine appearance against all odds. The mechanism for this cleaning process remains one of the great unsolved mysteries of planetary science. The rings also exhibit a kind of cosmic weather system, with density waves propagating through them like ripples on a pond. These waves, triggered by gravitational interactions with Saturn's moons, create patterns of compression and rarefaction that sweep around the rings at different speeds. Some waves spiral inward, others outward, creating an ever-changing tapestry of light and shadow that no human artist could imagine. Perhaps most intriguingly, the rings seem to be actively evolving. They're not static structures, but dynamic systems that change over time. New gaps appear, old ones close, and the very particles that make up the rings are constantly being recycled through processes we're only beginning to understand. It's as if Saturn's rings are less like a piece of jewelry and more like a living ecosystem, constantly adapting and changing in response to the complex gravitational and electromagnetic environment around Saturn. The mystery deepens when we consider the rings' thermal properties. Despite being made of ice, they don't behave as we might expect. Different parts of the rings have different temperatures, creating thermal patterns that seem to follow their own mysterious logic. Some regions are warmer than others, some cooler, creating a complex thermal landscape that adds another layer to the ring system's enigmatic nature. And then there's the question of mass. Saturn's rings, for all their spectacular appearance, are surprisingly lightweight. The entire ring system contains only about as much material as Saturn's small moon Mimas, spread out over an area larger than the distance from Earth to the Moon. It's as if nature took a small amount of material and stretched it into the most magnificent display in the solar system, like a cosmic magician pulling an impossible trick. The rings also interact with Saturn's magnetosphere in ways that continue to surprise scientists. They absorb energetic particles, create their own electromagnetic signatures, and even influence the planet's radio emissions. It's as if the rings are not just passive ornaments but active participants in Saturn's complex electromagnetic environment. As we drift deeper into contemplation of these cosmic mysteries, we're reminded that the universe still holds secrets that challenge our understanding. Saturn's rings represent one of the most beautiful, unsolved puzzles in astronomy. A reminder that even in our age of sophisticated spacecraft and advanced instruments, nature can still surprise us with phenomena that seem almost too elegant, too perfect to be real. The rings continue their ancient dance around Saturn, indifferent to our questions and theories, maintaining their spectacular beauty through processes we're only beginning to comprehend. Looking at Saturn's rings and the mysteries that continue to perplex scientists, we find ourselves confronting one of the solar system's most enduring enigmas. These celestial bands of ice and rock have challenged our understanding for centuries, and even today, with all our advanced technology and space missions, they remain beautifully defiant of complete explanation. The rings present us with what astronomers call the age paradox. While Saturn itself formed over 4 billion years ago alongside the other planets, mounting evidence suggests its magnificent ring system might be surprisingly young in cosmic terms, perhaps only a few 100 million years old. This revelation came as a shock to planetary scientists who had long assumed the rings were primordial features, ancient remnants from the solar system's chaotic birth. The Cassini spacecraft, during its spectacular 13-year mission that ended in 2017, provided us with unprecedented insights into ring dynamics while simultaneously deepening the mystery. The probe revealed that these seemingly solid bands are actually composed of countless individual particles, each following its own precise orbital path around Saturn. From tiny grains smaller than sand to boulders the size of houses, billions upon billions of these icy fragments dance in gravitational harmony, creating structures so thin they would be invisible if viewed edge-on from Earth. What makes this cosmic choreography even more remarkable is how the rings maintain their intricate structure despite constant bombardment from space debris and the relentless tug of Saturn's gravity trying to pull them inward. The answer lies partly in the gravitational influence of Saturn's many moons, particularly the so-called shepherd moons like Prometheus and Pandora that patrol the ring edges, corralling wayward particles back into line through their gentle gravitational nudges. Yet this shepherding effect alone cannot explain the ring's persistence. Scientists have discovered that the ring system possesses an almost organic quality, constantly recycling and renewing itself through processes we're only beginning to understand. When particles clump together and grow too large, they're torn apart by tidal forces. When gaps appear, gravitational resonances with distant moons work to fill them in. It's as if the rings have their own immune system, constantly healing and adapting to maintain their ethereal beauty. The mystery deepens when we consider ring rain, a phenomenon where charged particles spiral down Saturn's magnetic field lines and rain into the planet's atmosphere. This process should have eroded the rings entirely within tens of millions of years. Yet here they are, seemingly defying this cosmic weathering. Something must be continuously replenishing the ring material, but the source remains tantalizingly unclear. Perhaps most puzzling are the ring spokes, ghostly radial features that appear and disappear like cosmic weather patterns. These spoke-like structures, first noticed by Voyager and later studied in detail by Cassini, seem to form through electromagnetic forces that lift tiny particles above the main ring plane. They rotate with Saturn's magnetic field rather than following orbital mechanics, creating an ethereal dance that looks almost supernatural when viewed in time-lapse photography. The composition of the rings tells its own mysterious story. They're made almost entirely of water ice, remarkably pure compared to the dirty snowballs we see in comets and asteroids. This purity suggests either a very specific origin or ongoing processes that somehow clean the ice, removing rocky contaminants that should accumulate over time. Some scientists propose that the rings formed from the destruction of an icy moon that wandered too close to Saturn, while others suggest they're the remains of comets captured and shredded by the planet's immense gravity. Temperature variations across the rings add another layer to the puzzle. Different regions show distinct thermal signatures that change with Saturn's seasons, which last about 7 Earth years each. These temperature differences affect how particles clump together and how they interact with Saturn's magnetosphere, creating feedback loops that influence ring structure in ways we're still trying to decode. The gravitational interactions within the ring system create waves and resonances of staggering complexity. Density waves propagate through the rings like ripples on a cosmic pond, triggered by the gravitational pull of Saturn's moons. These waves transport angular momentum and sculpt the ring structure, creating the thousands of individual ringlets that give the system its record-like appearance. Mathematical models struggle to capture all these interactions, requiring supercomputers to simulate even simplified versions of ring dynamics. Perhaps most intriguingly, recent observations suggest the rings may be more active and dynamic than previously thought. Features appear and disappear on timescales of months or years, suggesting ongoing processes that reshape the ring structure. Propeller-shaped disturbances, likely caused by embedded moonlets, create temporary gaps and waves as they plow through the ring material. These moonlets, too small to see directly but detectable through their gravitational influence, may hold keys to understanding how the rings formed and evolved. The vertical structure of the rings presents another enigma. While incredibly thin relative to their diameter, the rings do have measurable thickness that varies across different regions. Some areas show periodic thickening and thinning, possibly driven by gravitational resonances or electromagnetic effects. This vertical dynamics adds three-dimensional complexity to what might appear from a distance to be a simple flat disk. Saturn's magnetosphere plays a crucial role in ring dynamics, creating charged particle environments that can levitate dust grains and create the mysterious spokes. The interaction between ring particles and magnetic fields generates radio emissions that change with Saturn's rotation, providing a cosmic radio beacon that scientists use to study both the rings and the planet's interior structure. The chemical composition of ring particles shows subtle variations that hint at different origins or evolutionary processes, while predominantly water ice, trace amounts of other materials create slight color differences visible in high-resolution images. These compositional variations map onto ring structure in ways that suggest complex relationships between particle dynamics and chemistry. As we continue studying Saturn's rings through ground-based telescopes and future space missions, each new observation seems to raise more questions than it answers. These magnificent structures serve as a natural laboratory for studying gravitational dynamics, particle physics, and planetary formation processes. They remind us that even in our own solar system, profound mysteries await discovery. The rings of Saturn stand as a testament to the universe's capacity for creating beauty through the interplay of simple physical laws. They challenge our understanding while inspiring our imagination, proving that some of nature's most spectacular creations remain tantalizingly beyond our complete comprehension. Looking at the incredible mysteries that Saturn's rings continue to present to us, we find ourselves at the culmination of a journey that began with simple observations and led us deep into the heart of one of the solar system's most beautiful enigmas. We've explored the delicate architecture of these cosmic structures, witnessed their dynamic behavior, and marveled at their seemingly impossible existence. in the harsh environment of space. The rings of Saturn embody a fundamental paradox that runs throughout our understanding of the cosmos. They are simultaneously ancient and young, stable and dynamic, simple and incomprehensibly complex. Their very existence challenges our assumptions about how planetary systems evolve and persist over cosmic time. Every new observation, every detailed measurement, every computer simulation seems to deepen the mystery rather than resolve it completely. Consider the elegant precision with which these rings maintain their structure. The countless ice particles that comprise them, each no larger than a snowball, somehow organize themselves into distinct bands separated by gaps so precise they can be measured to the meter. The shepherd moons that patrol the ring edges, the resonances that carve out divisions, the spokes that appear and disappear like ghostly fingers reaching across the ring plane. All of these phenomena speak to a level of organization that emerges from apparent chaos. Yet beneath this apparent order lies a system in constant flux. The rings are not static monuments to some ancient catastrophe, but living, breathing structures that respond to the gravitational symphony playing out in Saturn's neighborhood. They pulse with the planet's magnetic field, dance to the rhythm of passing moons, and reshape themselves in response to the endless bombardment of micrometeorites and cosmic debris. The question of their origin remains tantalizingly open. Did they form from the violent destruction of an ancient moon, torn apart by tidal forces as it ventured too close to Saturn? Are they the remnants of primordial material that never quite managed to coalesce into a satellite? Or might they be much younger than we imagine? Perhaps the result of a relatively recent collision that scattered ice and rock throughout Saturn's equatorial plane. Each possibility carries its own set of implications and challenges. If the rings are ancient, how have they survived the relentless erosion that should have ground them to dust eons ago? If they are young, what cosmic accident could have created such a perfectly organized system in such a relatively short time? The evidence points in multiple directions, creating a puzzle that continues to frustrate and fascinate researchers. The dynamics of ring particle behavior reveal another layer of complexity. These tiny fragments of ice and rock don't simply orbit Saturn in neat, predictable paths. They collide, aggregate, and break apart in an endless cycle of destruction and renewal. They form temporary clumps that survive for hours or days before dissolving back into the general population. They create waves that propagate across the ring plane like ripples on a cosmic pond, carrying information about disturbances from one region to another. The role of Saturn's magnetosphere adds yet another dimension to the mystery. The planet's magnetic field doesn't just passively contain the ring particles, it actively shapes their behavior, creating the enigmatic spokes that appear and disappear with the planet's rotation. The interaction between charged particles and ring material creates a complex electromagnetic environment that we're only beginning to understand. Perhaps most intriguingly, the rings appear to be teaching us about processes that operate throughout the universe. The same physical mechanisms that govern ring dynamics, gravitational resonances, tidal forces, electromagnetic interactions, play out on scales from the smallest asteroid systems to the largest galactic structures. Saturn's rings serve as a natural laboratory where we can observe these fundamental processes in exquisite detail. The precision required to maintain such delicate structures over millions or billions of years speaks to the incredible sensitivity of gravitational systems. The slightest change in mass distribution, the smallest perturbation from a passing object, even the gradual evolution of Saturn's interior could potentially destabilize the entire ring system. Yet somehow, these gossamer structures persist, maintaining their beauty and complexity against all odds. As we continue to study Saturn's rings with ever more sophisticated instruments, we're discovering that they're far more complex than early astronomers could have imagined. What appeared through telescopes as solid bands are revealed to be intricate tapestries of structure within structure, patterns within patterns, extending down to scales limited only by our ability to observe them. The rings also serve as a reminder of the dynamic nature of planetary systems. They show us that even in the apparent stability of the outer solar system, dramatic changes can occur. Moons can be destroyed, new structures can form, and the gravitational architecture of a planet can be completely transformed. They hint at the violent history that lies hidden beneath the serene appearance of our cosmic neighborhood. Looking toward the future, Saturn's rings face an uncertain fate. They continue to lose material to the planet's atmosphere, spiraling inward under the influence of magnetic forces and atmospheric drag. Some models suggest they may disappear entirely within the next few 100 million years, making them a temporary ornament in cosmic terms. Others propose that they may be continually replenished by ongoing processes, perhaps the occasional disruption of small moons or the capture of passing comets. The study of Saturn's rings has also revolutionized our understanding of how such structures might form around other planets. We now know that all the giant planets in our solar system possess ring systems, though none approach Saturn's in grandeur. We've discovered rings around asteroids, and we suspect that ring systems may be common features of planets throughout the galaxy. Each new discovery about Saturn's rings raises fresh questions and opens new avenues of investigation. The Cassini mission's detailed observations revealed phenomena that theorists are still working to explain. The discovery of oxygen in the ring environment, the identification of complex organic molecules, the detection of water geysers from nearby moons. All of these findings add new layers to an already complex story. The mathematical models used to describe ring dynamics continue to evolve, incorporating ever more sophisticated treatments of gravitational interactions, electromagnetic effects, and particle physics. These models not only help us understand Saturn's rings, but also provide insights into the behavior of accretion disks around forming stars, the structure of spiral galaxies, and the dynamics of debris disks around distant planets. The rings also serve as a testament to the power of scientific observation and analysis. From Galileo's first puzzled observations through Huygens' recognition of their true nature, from Maxwell's mathematical analysis to the detailed spacecraft observations of recent decades, our understanding of Saturn's rings has grown through the patient accumulation of evidence and the gradual refinement of theoretical models. Yet for all our scientific progress, Saturn's rings retain their power to inspire wonder and contemplation. They remind us that beauty and mystery can coexist, that the universe is capable of creating structures of breathtaking elegance through the operation of simple physical laws. They challenge us to look beyond the obvious, to question our assumptions, and to remain open to the possibility that nature may be far more creative and complex than we imagine. In the end, Saturn's rings represent more than just a planetary phenomenon. They embody the ongoing dialogue between observation and theory, between what we see and what we understand, between the beauty of the natural world and our human desire to comprehend it. They stand as a beautiful mystery that science continues to explore, a reminder that even in our age of space exploration and sophisticated instrumentation, the universe still holds secrets waiting to be discovered. As we drift towards sleep, we can take comfort in knowing that Saturn's rings continue their ancient dance, unmarked by our struggles to understand them, beautiful in their complexity, mysterious in their persistence, and eternal in their ability to inspire wonder in anyone who takes the time to contemplate their graceful presence in the darkness of space. They are a gift from the cosmos, a reminder that mystery and beauty are not diminished by scientific inquiry, but rather revealed in ever greater depth and detail. The rings of Saturn will continue to challenge our understanding, to inspire our curiosity, and to remind us that the universe is far stranger and more wonderful than we can possibly imagine. In their delicate balance between order and chaos, between stability and change, between the known and the unknown, they reflect the very essence of scientific discovery itself, the endless quest to understand the beautiful mysteries that surround us in the cosmos. And so, Saturn drifts on, a ghostly giant wrapped in wind and silence, wearing rings that may vanish within your lifetime. We used to think we understood this planet, but the closer we look, the more Saturn teaches us that beauty in space often hides something stranger, something science still can't explain. Thanks for joining this quiet journey tonight. If you're still awake, I'd love to know where you're watching from or dreaming from. Until next time, sleep well and keep wondering. This is Boring Science, and good night. Cheers.